Hello, and welcome to the first episode of Around the Oval, where we deep dive into one current topic in the world of track and field. For our first topic, we'll be looking at a recent rule change made by World Athletics that will take effect ahead of the World Championships. That is, the mandatory once-in-a-lifetime SRY gene testing all athletes will have to undergo ahead of the World Championships to compete in the female category. I would like to start by acknowledging that this subject can be contentious. While some people feel the new testing rules may increase the integrity of the sport, others feel that it has the potential to unnecessarily discriminate against select athletes. The goal of this video isn't to take a stance on whether the decision to bring in sex testing is right or wrong, but simply to inform you about what is happening. Okay, with that out of the way, let's dive in. According to the World Athletics official press release, all athletes wishing to compete in the female category at the World Championships are required to undergo a once-in-a-lifetime test for the SRY gene, a reliable proxy for determining biological sex. This is to be conducted via a cheap swab or a blood test, whichever is more convenient. The testing protocol will be overseen by member federations as they prepare their athletes and teams for the championships in Tokyo. Okay, well, what does this test actually do? You're going to have to think back to high school biology for a second. Humans have 23 pairs of chromosomes that contain all their genetic information. You receive one copy from your mom and one copy from your dad. One of these 23 pairs are referred to as your sex chromosomes. They're classified as X and Y. Biological females have two X chromosomes, while biological males have an X and a Y chromosome. Now, this applies to most people in the population, but a small number of people have what are now referred to by researchers as disorders of sex development, or DSDs. DSDs encompass a group of conditions that affect the development of the sex chromosomes, or the external genitals. People with DSDs may have ambiguous external genitals, delayed or abnormal puberty, sex chromosome combinations that don't match the typical XX or XY patterns. This is the case in people with conditions such as Klinefelter syndrome, where a person has XXY chromosomes. Other potential combinations include XYY syndrome, XXXY syndrome, or XXYY syndrome, all named for the particular genetic change. You may have also heard the term intersex to describe people with biological features not prototypically male or female. The term DSD is now typically preferred over intersex in medical context, and is the term we'll use since it's what World Athletics uses in its eligibility guidelines. Estimates on how common DSDs are vary, but there might be around 1 or 2 cases per 10,000 live births, or roughly 0.01 to 0.02% of the population. The highest recognized estimate puts this number at 5 to 170 cases per 10,000 live births. Now, obviously, World Athletics and the IOC currently break down athletics competitions into 2 categories, male and female. For the most part, people who are biologically male compete in the male category, and people who are biologically female compete in the female category. But where things get a little murkier is when trying to decide which category people with DSDs should compete in. Some, but not all people with DSDs may have advantages over biological females with XX chromosomes. This is where the SRY gene test comes in. This test determines the presence of sex-determining region Y protein, or SRY, found on the Y sex chromosome encoded for by the SRY gene. It's not found in females with XX chromosomes, but is found in people with DSDs with at least one Y chromosome. The SRY gene plays an important role in the development of male genitalia in the womb, but malfunction may lead to complete or improper development, leading to situations where a person has XY chromosomes, but anatomically develops as female. At least in track and field, the controversy is effectively limited to situations where people with a Y chromosome compete in female events. Although it's worth noting, World Athletics does restrict participation in male category to biological males and females who have used testosterone as part of male-affirming treatment. The rationale for bringing in mandatory SRY tests is to maintain fairness in the female categories. As reported in the World Athletics press release, the president of World Athletics, Sebastian Coe, said, "The philosophy that we hold dear in World Athletics is the protection and the promotion of the integrity of women's sport. It is really important in a sport that is permanently trying to attract more women that they enter a sport believing there is no biological glass ceiling. The test to confirm biological sex is a very important step in ensuring this is the case. We are saying, at the elite level, for you to compete in the female category, you have to be biologically female. It was always very clear to me and the World Athletics Council that gender cannot trump biology." Okay, obviously this is a very nuanced issue and there's room for debate on whether World Athletics is making the right decision. On the surface, the rationale does seem like a positive one, but as we'll look at later, there may be some reasons why it doesn't entirely meet these goals. Biological sex testing in competitive sport isn't a new concept, and it dates back to at least the 1900s. At the Olympic level, the issue first arose ahead of the 1936 Olympics held in Berlin. Stella Walsh, a Polish-American athlete, had already won the gold medal in the 100-meter in Los Angeles 4 years before. She had a muscular pattern and facial characteristics that prompted the press to nickname her Stella the Fella, and she was publicly accused of being male. Walsh would finish second to Helen Stevens in 1936, another woman publicly accused of being a man. At the time, there was no formal gender verification program, but the Olympic Committee did perform a rudimentary sex test, which simply involved genital inspection. For Stella, they confirmed her female after this test. After her death in 1980, examination confirmed that she had ambiguous genitalia and abnormal sex chromosomes, although which DSD she may have had was never established. Many other controversial cases would appear over the next 30 years until gender verification was introduced prior to the 1966 European Championships in the form of so-called nude parades. Here, female athletes stood naked in front of a committee and had their external genitals examined. Of the 243 women present in the first examination, none were barred from competition. But, notably, a pair of Russian sisters, Irina and Tamara Press, who had set 26 world records in athletics between them, didn't appear in the examination and never competed in athletics again after. It's been widely speculated that this may mean that they had DSDs and ambiguous genitalia, but has never been proven. Clearly, these nude parades were criticized for being demeaning to the athletes and luckily didn't last long. Ahead of the 1968 Olympics, the sex verification was switched to a bare body detection test, which used a cheek swab to determine biological sex. This test works by looking for a genetic marker called the bare body, which is only found in cells of XX sex chromosomes. Although arguably a better system than the previous nude parades, the bare body test had its own issues. Since it relied solely on genetics, people with XXY chromosomes and very high levels of testosterone would be able to compete since they had two X chromosomes. But people with a condition called complete androgen insensitivity syndrome that likely wouldn't provide an advantage would not be able to compete. We'll look at this condition a little bit later since it also applies to World Athletics' current guidelines. The bare body test led to the disqualification of the Polish sprinter Iwa Klobowska, who had won the European Championships in the 100 meter and silver in the 200 meter. The ban was on the grounds of having one chromosome too many. It's now believed that she had a rare condition called XXXY mosaicism, where some cells have XX chromosomes and some have XXY chromosomes. She passed the anatomical test in the nude parade the year before, and would later mother a child. After her case, the IOC began keeping test results a secret to protect the athletes from humiliation. In 1991, the bare body test was replaced with analysis of the SRY gene. At the 1992 Barcelona Olympics, 2,000 women were tested and 15 reported positive for the SRY gene. In 1996, at the Atlanta Olympics, 8 of 3,000 tests were positive for this gene. Of these 8 athletes, 7 were found to have androgen insensitivity syndrome. The testing was suspended in 1999 after years of debate, but the IOC maintained the authority to request it on a case-by-case basis. Okay, let's circle back to the new World Athletics guidelines that will come into effect as of September 1st. In these eligibility rules, biological male refers to a person with a Y chromosome, and biological female means someone with no Y chromosome, irrespective of their legal sex or gender identity. According to Rule 3.5.2, only the following athletes may compete in the female category. A. Biological females. B, and this one is a bit of a mouthful, biological females who have used testosterone as part of the male gender affirming treatment further to therapeutic use exemption granted in accordance with World Athletics anti-doping rules may not compete in the female category until the passing of a period of time after last use with testosterone. The period of time will not be shorter than 4 years and will be determined by World Athletics on a case-by-case basis, taking into consideration all relevant factors, including timing, duration, dosages, and effect of male gender-affirming treatment. C. Biological males who have complete androgen insensitivity syndrome and therefore have not gone through male sexual development, including any type of male puberty. D. Biological males with a difference of sex development who satisfy transitional provisions issued by World Athletics. Okay, let's take a deeper look at Section C and complete androgen insensitivity syndrome. This syndrome is a medical condition where a person who's biologically male with testes and produces testosterone has malfunctioning receptors to these hormones. High levels of androgens in the womb normally cause male characteristics, but since these people don't respond to these hormones, they develop female external genitalia, despite having testicles instead of ovaries. Usually, people with this condition are raised female and identify as female. While World Athletics rules make an exception for complete androgen insensitivity syndrome, it's important to note that androgen insensitivity syndrome exists on a spectrum, and this represents the most extreme case. D is a little more difficult to explain concisely, but effectively, it means that some biological males with DSDs who take hormone therapy to keep testosterone suppressed can continue to compete in a female category if they were previously eligible before the rule changes. Notably, this doesn't include trans athletes, since in 2023, World Athletics voted to ban them from elite female competition if they have undergone male puberty. Research is still ongoing on the subject, but the decision, acknowledged by World Athletics as potentially contentious, came after some studies suggested that even after a year of hormonal therapy, trans women may still maintain physical advantages over cis women. Now, you're basically caught up on what the SRY test is, why it's being brought in, and how it affects eligibility guidelines. Now, let's take a look at some of the criticisms against it. In the World Athletics fact document, they state, the SRY gene test is extremely accurate and the risk of false negative or positive is extremely unlikely. Okay, that sounds great. However, some experts have criticized the newly required test under the pretense that it may be poorly executed, especially in developing countries and due to potentially omitting some females from competitive sport who don't have an inherent advantage. In an article published in The Conversation earlier this week by Andrew Sinclair of the Murdoch Children's Research Institute, he criticizes that science doesn't support World Athletics' assertion the SRY gene is a reliable proxy for determining biological sex. He takes the stance that the test shouldn't be used to ban females from competition. Sinclair was the lead researcher in a study published in Nature in 1990, where this gene was reported for the first time. He has continued to research other genes required for testicle development over the past 35 years. In his article, he goes on to point out that although the SRY gene triggers a cascade of events at 6 weeks of development that result in testicle development, if this gene doesn't function properly, then a person can fail to develop testes and be biologically female despite carrying XY chromosomes. Additionally, women who have complete androgen insensitivity syndrome with a functioning SRY gene have female external genitalia but internal testes. Despite having testes, their tissues are unable to utilize excess testosterone. Sinclair also points out that developing countries may not have the resources to send the samples to a lab, and processing by a male technician could contaminate samples with skin cells that could produce false positives. Member federations are responsible for testing their athletes, and it's fair to speculate that certain federations may not fulfill the requirements properly. Nigeria, in particular, has been under fire in recent years for making administrative errors that have barred their athletes from competition. So, what's the final verdict on SRY gene tests? The unfortunate truth is that no matter which method is used to determine competition eligibility, there will be some athletes left on the outside. There's likely no perfect system, and there's probably no solution that will satisfy everybody. The reality is these tests are being brought in, so for the time being, we'll have to deal with them for better or for worse. Given some of the legitimate concerns with the execution and results of the tests, it's likely worth continuing monitoring the results to see if there's evidence of them achieving their desired goals. Alright, that's it for our first breakdown. Thanks for watching, and we hope to see you next time.